So are you seeing my dias properly?
Yes. Yes.
Okay, so sorry, so this is the second. So I'm gonna talk to you about EPOS GNSS product, and I will try to present you what are the different products that we are developing in the frame of EPOS GNSS, and I will try to explain to you what kind of product you can use for what usage. So my name is Socquet. I'm sorry. So my name is Socquet. I'm the coordinator for EPOS GNSS Products, and I'm a member of EPOS GNSS Executive Board. As you can listen, I'm French. I'm working at Université Grenoble-Alpes, and I'm working on those products together with several people who are listed here from UB, INGV, Europe Observatory of Belgium, VUT, BKG, Landmatricht, and LTK in Hungary. So you can see here the workflow that is being developed since a few years in the frame of EPOS GNSS. So you have seen this workflow already in the presentation of Rui Fernandez yesterday, or the presentation of Karin or other people. So EPOS is not fully operational yet. So this workflow is something that is working more or less well, but since the products that I'm gonna explain today are arriving at the end of the chain, not everything is completely fully operational, but we are doing our best to meet operational objectives. So the objective of this webinar is really to explain this part of the products. This part of the chain, which is the products. So the GNSS products are gathering different type of data. So we are gathering RINEX data that are available from the GNSS data gateway. And we are also gathering regional daily solutions that are provided by national providers. So we have different contributions for EPOS GNSS products. We have pan-European service providers who are the people who are really part of the EPOS GNSS consortium board, but we are also benefiting from a lot of work that is made by local analysis centers that are institutions that provide solutions at the national or regional level. So who contributes to EPOS GNSS products? So as I said, there are two types of contributors to EPOS GNSS product, the pan-European service providers and the national contributions to EPOS GNSS products. For the pan-European service providers, you can see here you can see here the different institutions that are contributing. So we have 5 analysis centers that are located in Belgium, in Poland, in Hungary, in Italy, and in France. We have 1 product gateway that is located here in Portugal, and we have 3 other product-related services at BKG. They are hosting the repository for the daily solutions, the Landmatricht in Sweden, and they are generating the strain rates. And in UGA, I'm coordinating those different products. Then we have also national contributions to EPOS GNSS products, notably through UREF. So we have 16 UREF analysis centers that are contributing to UREF products, and they are located in Sweden, in Poland, in Germany, in Slovakia, Hungary, Serbia, Italy, Austria, Switzerland, France, Spain, and Belgium. And we also are benefiting from the help of 30 analysis centers that are contributing to the joint EPOS and UREF densified solution that is generated at LTK. And those different analysis centers are located in Iceland, Norway, Sweden, Finland, Estonia, Latvia, Lithuania, Ukraine, Romania, Bulgaria, Turkey, Greece, Hungary, Slovakia, Poland, Czech Republic, Germany, Denmark, Belgium, UK, France, and Spain, Switzerland, and Italy. What are the products that we are distributing and generating? So the GNSS products are products that are issued from different processing steps and that are starting from the RINEX file. So the first products are weekly or daily positions in the form of a SINEX file. So this is a position for each of the station at one given day. Then from those daily position, you can generate multi-year solutions. And from those multi-year solutions, you can extract position time series on a weekly or daily basis. So here you can see a position time series. So you have the evolution of the position with time of one given station in the north, east, and up component. And in the case of this station, you can see that there is a strong change in position here at this date, and this is associated with one given earthquake. So you can see the movement before the earthquake, the movement associated with the earthquake, and the movement that follows the earthquake after the earthquake. Then the third type of product that we are delivering are secular velocities. So those velocities are velocities that are extracted from the time series. And these velocities really represent the long-term or the interseismic velocity at each station. So the idea is really for these velocities to give the velocity that is representative from the tectonic plate, from the secular velocity. So the offsets associated with earthquakes, for example, are not affecting those velocities. And those velocities, you can have them in 3D. So you have the 2D velocity field, and you have also the vertical velocity field that you can see here, where the different colored dots show whether you have uplift, like here in the Alps, for example, or subsidence here in the Venice area, for example. So those secular velocity fields can be downloaded in different reference frames. So you can use them in a geodetic reference frame like the ITRF, for example, or you can also download them with respect to one given tectonic plate. And here you can see that it's represented with respect to stable Europe. And then the last type of GNSS product that we are developing and delivering are strain rate maps. So those strain rate maps are computed from the secular velocity field. So those train rate maps do not depend on the reference frame that you are using. So whatever the input, the reference frame in input that you are putting, you will obtain similar train rate maps. But those train rate maps can differ a lot depending on the way you compute them, whether you have a lot of smoothing or not, whether you have areas that are with a lot of stations, areas that are less dense in terms of stations. So you have to keep in mind that those train rate maps can vary a little bit from the people who are generating them. And so here you have two examples. So you have the second invariant of the strain rate. So it gives you the amount of deformation in one given area. So you can see that here in stable Europe, you have little deformation, more deformation here in the Apennines or in Greece or in Turkey. And you can also have information that give you information on the tectonic style associated with one given area. So you can know whether you have east-west compression or extension in such direction, or if you are in a strike-slip regime, for example. Associated with those train rate maps, we also deliver rigid rotation maps that can be downloaded as well. Okay. So we are developing different type of products, as I said, and we have from the portal, we have different labels and we have different processing centers. So what are those different product labels and what are their specificities? So we have three main product labels: EPOS, UREF, and EPOS UREF. So I'm gonna explain. I have 3 slides that are a bit busy here and that will explain what is the objective and the principle on which those different products are developed. So here it's a slide that explains the EPOS product. So the EPOS product are 2 product solutions that have been developed specifically for EPOS. So the principle is really simple. It's based on open science and reproducibility. So the idea is that those products are made using data that are fully available based on RINEX files that are from the EPOS GNSS data gateway. So, and we also use metadata that are available and verified. So we are providing time series and velocities for all the data, the RINEX files that are available from the data gateway. And at the moment, there are about 600 stations with time series available at the product portal. Because of course, when you have some of the stations have only a few RINEX files, so we cannot provide any time series associated with those stations, unfortunately. Then the idea is to have something that is reproducible. So the processing strategies are fully documented and the processing is made using open source software. So if you follow the different guidelines and the informations that are available from the product gateway, you should be available to reproduce exactly the same time series. So it's really based on open data and reproducibility. And then these solutions are specifically designed for geophysical studies. So we are generating 2 different solutions, and each of these solutions is internally consistent, and it's generated at a single pan-European processing center with one given strategy. So this gives you a good accuracy between different stations, and it can be usable for slow movements. So if you want to look at the movement between two stations in stable Europe, you will be able to have that with a great accuracy. So you can extract the internal strain from those stations. But you can also, for example, look at potential transients and slow slip events, for example, using those solutions. So those solutions are generated at two pan-European analysis centers, one in UGA in France and the other one in INGV. So the objective was to provide two independent solutions using different processing strategies. So one is in double difference, the other one is in PPP. One is using gamete globk PX, and the second one is using Gypsy Oasis 2. Both solutions are updated regularly, but in UGA, we are trying to provide automatic updates at D-2 and D-25 in order to have updated time series. And so those solutions are verified internally. So there is a rejection of outliers that is automated. We introduce discontinuities in the time series when you have offsets and documented offsets, notably, that is in the metadata. And then the velocity fields are computed with MIDAS. And we classify also the quality of the stations based notably on the uncertainty, on some uncertainty criteria. And then those two solutions are validated independently in LTK. So we have this quality check. So there is a comparison of the position time series using CATREF. Outliers and inconsistencies are identified, and there is a feedback to the EPOS analysis center or a validation. And this way the products are uploaded on the portal. So then we can move to the second label of products. So this second label is EUREF. So this is the original EUREF product that is also now made available through the EPOS GNSS product gateway. So the principle is based on open data. All the RINEX are available from the EPN data centers, and the metadata are available and verified. Those solutions are specifically designed for geodesy and for reference frame studies. So these solutions are including only the EPN stations, which are geodetic class stations from the EUREF permanent network. And those solutions are meant to densify ITRF over Europe and provide access to the European terrestrial reference frame. So the principle is based on a common effort. So we have regional daily position solutions that are processed at 16 EPN analysis center. So each station is processed by at least 3 analysis centers to ensure redundancy and increase reliability. 3 softwares are used among these 16 analysis centers. So some use Gnss, others use gamete, others use Gypsy. Then those regional daily position solutions are combined together into a daily or a weekly position at WUT in Poland. So this pan-European combination is made with Gnss. Each analysis center solution is compared to the combined solution to identify and reject outliers, and the solutions are then aligned to the IGS-14. And then those daily or weekly positions are then combined into a multi-year solution at the EPN Reference Frame Analysis Center in Robe, in Belgium. So this is made using Catref. There is an update each 15 weeks, and time series and position time series and velocities are then visually inspected. Based on this visual inspection, outliers can be rejected, and then also discontinuities in positions and velocities can be introduced or introduced. Station quality is evaluated, and stations are classified based on velocity uncertainties from Hector and velocity variability. Then the third type of product is this EPOS URF densified product. So this is a densification product from URF and EPOS. And you can see that for this product, we have much more stations that are available from the product gateway. And so the principle here, it cannot be based, it's not based on open data, but the idea is to provide a densified velocity field, including stations that are not EPOS stations and that do not release raw data yet. But of course, eventually the objective would be that the different stations that are included in this solution could release their data in order to have something that is really open and reproducible and very useful for science, including for people who are doing, for example, earthquake studies, etc. So this product is using it is based on the combination of regional daily position solutions that are generated at 30 analysis centers. So there are 28 EPN densified analysis centers plus 2 EPOS analysis centers. And any analysis center who would like to contribute to this solution is absolutely welcome to contribute to this solution. And so if you have, and if you are generating regional daily position solutions, you can provide your solution to LTK, and it will be included in this product. So these different analysis centers are using different softwares, either Bernice, Gamete, or Gypsy. And then all these solutions are combined into a multi-year solution at LTK in Hungary. So weekly combined solution time series are generated using Catref. The velocities are estimated and evaluated using Catref, Midas, and Hector. The station metadata are harmonized, and outliers are rejected by automated and visual inspection of the time series. Discontinuities are introduced when you have an offset in position and velocity. So this is based on visual inspection. Velocities are filtered, and non-representative stations are removed from the solution. And so non-representative stations can be due to poor data quality, for example, or to poor monumentation in some cases. So not all the stations are distributed. There is a filtering before. All right, so now we have several products. The question is, what do we use depending on what we want to do? So I've written here a couple of use cases that I hope span different examples. So you may ask additional questions if you have some. So the first use case is the case of, let's say that you're a structural geologist and you want to get the secular displacement rate and the strain rate map in one given area. And here I take the example of Spain. And so you can see here the secular GNSS velocity from the EPOS URF solution. So you can see that there is quite a dense data set in this area. So here it's plot with respect to stable Europe, and you can see very well this rotation of Iberia and the active movement here in the Baltic and across the Gibraltar Arc. You can see here also the style of deformation and the strain rates. So this is the second invariant of strain rate tensor. So you can see here that you pass from extension to compression and strike slip mode here in southern Spain. So the recommended product for this is the EPOS URF densified velocity field from LTK. And you can also download the strain rate product from Landmatriart. And you can also use additional products. So the EPOS velocity fields from INGV and UGA-CNRS. So those velocity fields will be less dense than this one. So this is why the recommended product will be this one here. And you can also use the URF velocity field from ROB URF rotated with respect to stable Europe. Now, let's try another use case. So let's say that you're a seismologist or an earthquake geologist, and you want to get the time series associated with an earthquake. And so here I take the example of the 2016 earthquake sequence in Italy. So it's a series of earthquakes that struck central Apennines in 2016. So there was the Amatrice earthquake, followed by the Norcia earthquake, followed by the Campotosto earthquake. And so the recommended product in this case is the EPOS daily time series from INGV or UGA-CNRS. And you can use additional products such as the URF daily time series from ROB URF. The problem with this is that it will be less dense than the previous one. And you can also probably use the EPOS URF densified time series from LTK, but the problem here is that it's gonna be a weekly time series, so you will not have the exact co-seismic displacement. So you can see here those different time series at different Italian stations. So you see here the north position time series, east and up for different type of stations. So you can see here for this station or this one that are quite to the north, sorry, that they are affected mostly by one earthquake, which is the Norcia earthquake. But when you go further south, so for example, when you look at this time series, here you see two earthquakes. So there is the Amatrice and the Norcia earthquake that are affecting this station. And if you go even further south, so at this station here, you see the Amatrice, the Norcia earthquake, and also the Campotosto earthquake. And you see pretty well also the post-seismic displacement that generates a transient displacement following the earthquake itself. So now let's take another case study. So let's say that you're a volcanologist, for example, or you could be also a seismologist or whoever, but you want to get updates on time series, recent updates in the area that is affected by a recent volcanic unrest or a recent earthquake, for example. In this case, the recommended product will be the EPOS daily time series from UGA-CNRS because this processing center provides a rapid updated solution. It's an automated solution. And then you could use additional products as time passes. And you could use also, of course, the EPOS daily time series from INGV, because INGV has always been distributing time series and as fast as possible when an earthquake happens. And you can also, of course, use the UREF daily time series from Rob UREF. That will be less dense probably, but that will be of interest. So here there are two examples. So this is an example on the Campi Flegrei in the Napoli area. And here it's an example in Mount Etna, and you can see the displacement associated with different phases of inflation and deflation before and after an eruption at Mount Etna. Here is a fourth use case. So let's say that you're a geodynamicist or a modeler and you want to compare the 3D velocities to constrain model of isostatic rebound, for example. In this case, the recommended product is the EPOS UREF densified velocity field from LTK. And you can additionally add as a product EPOS velocity field from INGV or UJA, and the UREF velocity field from Rob UREF. So here you see on this map, so the background color is showing you the model of glacial isostatic adjustment that has been published by Westall et al. In 2019. And superimposed on this model, you see the 3D horizontal and vertical velocities of EPOS UREF solutions. So you can see that in horizontal, you have a spreading in Scandinavia like this. And you can see that the agreement between the vertical here and the model is pretty good, at least in Scandinavia. Maybe there are some improvements to do to the model here in this area, and maybe those new data will allow the modeler to improve their models. And now here is a fifth use case. So let's say that you're a geodesist and you want to do some GPS processing and you want to get reference positions and velocities for your processing. So the recommended product in this case is to download the UREF position and velocities in SINEX format from Rob UREF with respect to ITRF 2014 or ETRF 2000 or 2014. You can also use additional products, which are the SINEX files that are derived from the EPOS position and velocities or the EPOS UREF position and velocities processed at UGS-NRS, INGV, or LTK. And here you see the velocities of the EPN stations with respect to ITRF in the ITRF 2014. Here you see the positions and the velocities of one given station at one given epoch in SINEX format. And here you see the same thing for the same station, but with respect to ETRF 2014. All right, so I think I've given a couple of explanations about these different products. I'm happy to take your questions. I thank you very much for your attention. And maybe the first question is, where can you get the EPOS GNSS products? And the answer is at the following portal. And I invite you to see the presentation about the product portal that will follow the question and answer session. Thank you very much.
Hi, everybody. I am Antonio Vallone, and I will help Anne for the questions. We already have two questions. The first is from Hans van der Marel. And Hans, do you prefer to ask your question by live or?
I can ask, can you hear me?
Sure.
Yes.
Hey, good afternoon, and thank you for the presentation. I had a small question. It's maybe a detail, maybe not, but you said you're using MIDAS, which is actually a median estimator using interannual pairs to estimate velocities. But why using MIDAS? Because if you use MIDAS, then you typically don't need the metadata, and MIDAS is insensitive to steps. And I think you already removed the steps because of antenna changes and earthquakes. And so you could also have used straightforward least squares approach. So basically,
Yeah.
that's the question.
Okay, thank you very much for this question. It's in fact, it's something that we have been debated a lot in the group, because of course everyone has his way of doing, etc. So the reason why we are using MIDAS to generate the velocity field for the EPOS product is because the idea is that we will have to process a large number of stations. So at the moment, it's only 600 stations, but it's going to increase. And we hope that it's going to increase a lot. So we are willing to be able to provide reliable station velocities. So we have reliable metadata, but sometimes we see in our time series that we have offsets that are not documented, or maybe offset that are associated, with a collapse, of, I don't know, the GPS station, or we have transients that is associated with the snow cover, etc., etc. And we cannot do this manual exercise to check manually all the time series if we want to provide updated products for a lot of stations. So the thing with MIDAS is that it's very, very powerful in extracting the secular velocity, because it's not very sensitive to offsets or to short transient deformations. So as long as you have a long time series, it's very powerful to get the secular velocity. So in the implementation phase, we have been developing this, and we have been checking that it's actually working. We have made a lot of tests, etc. And we are pretty confident that it's probably the best way and the most reliable way to provide velocities on a great number of stations, including in stable plate interiors where the velocities are small.
Yeah, okay, I agree with you, but then what's then the use of the metadata? Because it's a lot of effort to collect all the necessary metadata, and with MIDAS you're actually not really using it. And if you say drop this requirement for the metadata and also allow, it's nice to have it, the metadata, but if you also allow for stages that don't have it, then maybe you have much more data than you would have if you also require the actual metadata.
Yeah. Yes. So if we have good metadata, the good thing is that we can, use the proper antenna model, we can use the proper receiver model, etc. And we can give MIDAS also, we can tell it, okay, at this date, there should be a change. At this date, there should be a change. So you can tell it that there are changes. So it gives slightly better results. Also, for example, in EPM, they are not using MIDAS to obtain the velocities. The velocities are obtained by time series analysis that is made very carefully by Juliette Legrand, and she's really fitting using catref the different velocities. So yes, I agree with you. If we could have more data if we were not requiring exact metadata, but the idea is to provide data that are as good quality as possible. And the products are providing time series for all the EPOS Rhinex files. But for example, the EPOS URF densified solution is providing velocities also for stations that have metadata that is not double check and that is not as good quality as EPOS stations. So yeah, we are trying to open and to provide different type of products for this purpose, to be as inclusive as possible.
Yeah, okay, thank you.
We have other two questions, one from Andrea and one from Alessandro, who hands up his hand, virtual hand. So please, Andrea.
Yeah, hello everybody. My question is, you provide time series, for example, and velocities, okay, but for the time series manipulation, do you provide tools? For example, in the volcano case, you only want to extract a part of the time series and calculate either cumulative displacement or displacement rate on just one time interval to compare it with the second time interval. So I'm wondering if for this specific case or for a general case, you have tools so that users can manipulate the time series as they want.
Yeah, thank you, Andrea, for this question. It's a very good question. I think it's a very good point. At the moment, we are not distributing tools to manipulate the time series. At the moment, we are trying already to provide updated time series, updated products, etc. So it's already been a long journey, but probably in the future, I think it's a good idea to provide simple tools to extract the displacement over one given period. And several people are developing tools, so probably this could be a very interesting and positive contribution to EPOS to add time series analysis tools to EPOS. But time series analysis tools are available already in several areas and in several websites. So at the moment we are not, and we will probably think of this in the future. So it would be interesting to have users' feedbacks on that. If several people are asking for that, we should consider to do it. Yeah.
Yeah. Okay. It's a very nice idea. Anyhow, the products that you produce so far, it is an enormous work, and I congratulate all the team. In fact, to have come to that, it was just a thinking. In fact, to have tools together with the data that you can easily convert the data into the specific products that you would like. And I think I can anticipate maybe another question, that is how these products are integrated in the integrated core services. What is your business? But maybe this can be spared for the question and answer part after your talks.
Yes, that's okay. Let's keep this question for the Q&A session. Okay, thanks.
Okay. Alessandro Caporali, is your turn. I cannot hear you.
Can you hear me now?
Yes.
Okay, now it's okay.
Thank you. I was referring to the processing of the data. I noticed that you have both PPP and double difference.
Yes.
I wonder if there is any standard, any processing standard, and if the two PPP and double difference solution have been compared, and there is any agreement, or what level of agreement is there, particular for velocities? Thank you.
Yes, we have done this comparison work. In fact, we have done a first test on a prototype solution that was including, so when the data portal was not providing data yet, we have done, benchmarking to compare those different solutions. We are also documenting very precisely the different processing options that we are using, and both solutions are showing an excellent level of agreement, both for the position time series and for the velocities. And we have also this system of external check and validation of those different solutions that is made in Hungary at LTK, and Ambrus Gnss is comparing in great details the position time series, and he's giving us feedbacks on potential disagreements that we may have. But yes, both solutions are providing very close results.
Okay, I think for the moment it's time to conclude. We will leave the last questions in the chat for the question and answers session, and maybe I thank everybody, and also Anne. So Rui, as you want, you can.
Yeah, thanks, Antonio. It's time to move to the next and last presentation that will be done by Michiel Bos and about the products portal. Also, don't forget to, if you have any question during Michiel's presentation, focus on this presentation to put on the chat that you want to make a question, and he will be glad to reply during the time after. Otherwise, we'll leave it after for the last session. Thanks. Michiel, give you the just. I think you are mute.
Thank you, Rui. So you can see my screen now?
Yeah.
Okay. So in this presentation, it's about the product portal. As Rui said, I'm Michiel Bos, and this product portal has been made a bit by me, and more recently by José Matengairo, who has been working recently very hard on it. But it has a long history, and in the past we had lots of contributions by Rui, Paul Crocker, Rui Cardoso, Rafael Couto, and André Rodrigues, University of Beira Interior. So I also show here the figure, which you should now know very well by now. It's been shown in many presentations. So in the previous one by Anne, it was about the analyze centers, but now I will be talking about the product gateway. So all the data comes here, enters the ecosystem to the data gateway, is being analyzed by the analyze center, and then the positions and velocities, they're sent to the product gateway where they can be downloaded by the users. And then also these velocities are used to compute strains, which can also be downloaded by the user. So this just to position the product gateway in the rest of the TCS GNSS data and products. So now I'll talk about the product portal. So here is the URL. So gnssproducts.epos.up.pt. If you go there in a browser, you will see this. And the first thing it will ask is to accept cookies. So let's accept cookies. And then you have this welcome pop-up. So it shows the list of analysis and combination centers discussed in detail by Anne in the previous one, INGV from Italy, Landmateriaat from Sweden, LTK Euref, Hungary, ROB, Royal Observatory of Belgium, from UGA from France, and Warsaw University of Technology of Poland. We provide daily and weekly time series, and they're given in various reference frames. Then you can download the velocities, and we also have a strain map which you can download. In the bottom, you have the links from the GNSS Data Gateway, which was discussed by Mathilde and Jean-Luc yesterday, and the M3G gateway, where you can enter new stations or can enter their site log or change and update them. So let's go. So the first thing the user will see is this map with all the stations. So, and then these are the stations that are providing products. And then you can have time series, velocities, and strain rates, and also power spectrum I will talk later about. And then here you have filters, so you can already select some of them to limit the number of stations that you're seeing and want to download. So you can use the sliders to minimize it, and the networks, and you see that is update. I already want to say the network here, EPOS, we are in the pre-operational phase. So the stations, some of them are not yet EPOS station, but they're providing data, but that can be analyzed by analyze centers, but they're not providing yet the RINEX. So this EPOS network is actually kind of just a name to capture all the stations which are not in a network or which we don't know the network name. And then here you can filter the analyze centers. So you can also filter them, and you see that data. Okay, before I show any time series, I want to go about the information. We have here a button, information. So analyze center, documentation, and frequently asked questions. So analyze center, that's the first thing I will show. So you have here the list of analyze centers, combination centers, INGV from Italy, LM, Landmateriaat, LTK Euref, ROB, UGA from France, and WIT Euref. So you can click on them, and then you can already see some description about what they are. So with the URL and then the time series. So which software they were computed and in which reference frame. So the velocities that was already discussed also before. That was in the meter software in the case of INGV. We will also use that. So you can here find some quick information. So INGV and UGA were the EPOS group. And then you have the ROB and the WOOD of the EUREF group. WOOD is a combination center. So Anne already listed all of them. Here you can see they're also listed here. And here in LTK Europe, it's the densified solution. Yeah, also have all those analyzed centers that contribute to the densified. So they provide solutions, velocities, or time series, which then by Ambrus has been used to compute the densified solutions. In Landmateriaat, they are computing the strain rate, and they have been collaborating with Noah from Greece. So ROB gets them also from UTRF. So here it's just a list, and you can view it. Then if we go back and go to the documentation page, here, here you have very detailed information. The first is just for the analyze centers themselves, how to upload it. That's not very useful maybe for the user, but for the people who have to upload the products, it is. And then here you have PDFs files which show all the information was unset in the previous documentation presentation about outliers, how they were detected and removed, discontinuities, offsets, how they were detected using metadata or other methods, and how they were treated. So here, for each analyze center, you can read about that. And here, the processing procedures. These are reports and documents that have been collected over the years and written. So this one especially, it's more than 100 pages, and you can find lots of information. So if anyone wants to read more about the background information about how the things were processed, analyzed, this is a good document to find it. It's very detailed. So, yeah. Then the final one is about the frequently asked questions page. So here we state some general questions with answers. What's EPOS? I here only want to point out that we have a landing page. So we have also a nice landing page where you can find all this information. So if there, it's also good to start where you want to find more information. And for here the list. And then for now, maybe it's what I want to emphasize more is that there's here an example about the RESTful API. So it shows how you can automate this downloading. So I will go into detail, but here if people want to come back, they can find here an example. Okay, so let's try to look at some time series. You can click on here, and then you see it. You can see the time series. But now let's do it here. Also in the search box, search for it, and it comes here. So it gets updated, and then here you have a button to see the data availability or the product, so the time series. So they're in green, it's available. So we have data from 2008 to 2020, and then in the end, because the year we have not received it. So this is that. And then, so let's click on it. So here appear the time series. You can see that here. So you have the various steps, the various analysis center that provide time series, INGV, UGA, and ROB with the Europe group. The densified solutions of Ambrus will be added next week or in the coming days. So they are ready, but they need to be put on the product portal. Then if you go down, these are the east, north, and up component for the years. So you can use the browser. Then we download them. You can download them as a PNG file, as an XML, so a markup language, the format, so all the data of the time series comes in text, with text, is good for computers. And the PBO format, the plate boundary, it's a text file, I'll come back to that. Then the meters, so meters also has its own time series format. So if you download it in this format, you can directly put it into meters to estimate your velocity. And also you can use the Hector. Since I'm involved, of course, Hector should be there too. That's also a simple text format, and you can download it. And then all these data products are provided using the CC BY license. So if you go down, for each analyze center, you can see the 4-character name, the analyze center, which we're seeing, sampling pyramid, it's daily, the reference frame, the version, and then the DOI. So the DOI, if products come with a DOI, you can see it here, and then the start and the end epoch. Okay, so let's try to get to download it. You cannot do that because the philosophy of the product portal is that you can browse and see what's available, but to download it, you have to give your email address. This is done for two reasons. The first one is we would like to know who is using the product portal. And secondly, some of the requests you are making to download are sent back by email. So we need the email to send the results. So, but if you don't have an account, you can sign up. You give your first name, last name, email, and select a password. And then you can log in with your email and name, or you can use other login options. So one of them is the EPOS site. EPOS, it's EPOS, as we explained yesterday, our TCS, GNSS Data and Products, owns only one of the various TCS that exist. There is seismology, geology, near-fault observatory, and they all should be working together. So all the data available at the various portals at the other TCSs, you should be able in the future to all access them with a single login and password. So that's for the future. Let's go back. The other one is the Google. It's more common. It's log in with your Google account, or you can log in with ORCID for researchers who have an ORCID account. Type in and you can log in. Let's go back. So let's log in. I'm now logged in as Michiel. Let's go to floors. There, and download the PBO. So it's downloading. It doesn't know the application.tos, but okay. So I have done that. Here's floors. It's the fourth time I downloaded it just to make sure for this presentation. So I open it in a simple text editor. So you can see on the first line, it gives the reference frame. And then also the four character ID, floors, long name, first epoch, last epoch, release date, reference position. So here, the first lines, they explain the columns of the data. And the real data, they start here. So here, in this case, the data starts at 2008. And then you can see here the reference position in Cartesian here. And then the uncertainties. So this is the format people then can use in their software to get the time series. Another format is then the Hector format. Which is, it's similar, but it has less information. Modified Julian date, east, north, up in millimeters. So that can also be used. Let's go back to the presentation, to the time series. So I've shown you, you can download it and then show you the various formats that exist. So now let's go to velocities. So velocities already showing here. Let's go in. Velocities are shown by this line, with the line gives its orientation, so where the velocity is pointing to, and then the length of the line is the magnitude of the velocity. These are velocities with respect to stable Europe. So most stations in Europe are not moving. It's only in Italy when there's tectonic activity, where you can see some motion. And of course, in Greece and Turkey, there's a lot of deformation, which is clearly visible. And of course, you can again use the sliders to select, where EPOS is this general collective term to denote stations which have not, for which we don't know the network, or we did not have the information. And then you can also use the analyze centers. You can correct for that. So select station. in a single view, you can see here the velocity with respect to stable Europe for the northeast and up component. This is then the EPOS EUREF solution, the version number with the reference frame IGS14. The same for IGNV, UGA, where you also have, if it's known, we can also are giving here the DOI number. And then these are velocities with respect to stable Europe, but you can also check, you can play around and you can see no net rotation. So Tertiary, if it's absolute velocities, then they are moving northeast. Europe is moving a bit to the northeast. You can also check the velocity with respect to North America. So it's still not around zero. So Tertiary, although it's close to the mid-Atlantic ridge, it's more Europe than North America plate. So you can play around with that. Again, these data are provided with the CC BY, and that you can. So let's download it. So let's do a download for let's say ROB. So it's downloading them. Okay. And then I already did that before. It's there. So when you open that on the first line, you see where the data is coming from. So all the data is put on an FCFTP site. It's by ROB Europe, the reference frame, release date. So again, the first lines in this PBO plate boundary format, they're explained, and then here are the data. So this is how that works. So, okay. So far I've been talking about a single station. So let's go back to the time series, zoom out a bit. But suppose you want to select a region. So then you can, instead of the sliders, you can also use here a rectangle. So you can draw a rectangle. I will remove this here. It gets updated here. And then, so if you make a mistake, you can click on this bin symbol. If you see your mouse symbol changes when you go to the border, and you save it. So this is how you can work with it. Let's draw it again. And since I'm logged in as Michiel, you can download it. Then the selection, you give your email address, and then you can choose the format. So these are the formats I already talked about. So JSON, Hector, or PBO, submit. And then you get a download request. And within a few minutes, you should get in your email box the notification that you have received the product as a zip file. So that's that. And the same for the velocities. You can select it. Let's do another region. And then download selection. Then the email again. And then you can choose here the various analysis center, combination center that you want. You can do multiple, so you can add those. And then you can choose which format you want, JSON. Then you have the east, north, up. You check this slider, or the geocentric Cartesian ones, slider. And then, or you choose the PBO format, and then you submit the request. Again, it's the same, the download, and then after a while in your inbox, you get the file. So these are sent to you by email. So before talking about the strain rates, I would like to talk about the power spectral density. So if you go again to a station, let's see. So all the time series have been estimated with Hector, and then from the observations, the the secular trend has been subtracted and the residuals have been used to estimate the noise. It's well known that GPS time series have temporal correlated noise that follow quite closely a power law model. So in blue, you will have here the power spectral density observed from the residuals, and then in red, you have the fitted noise model, power law plus white. It's almost pure power law. And this here, the thin red lines give you the 95 confidence interval. So why do we do this? This is a bit to give you an indication about the noise levels. If there's a lot of noise at the low frequencies, your trend estimation will be bad. So this is a quality indication for your time series. You can use that to see if a station is good or bad. And we have done that for the various analysis centers for all the time series. Okay. Then finally, there is strain. The final product is strain rate. So these are the last in line. We have now Landmateriaat is working hard to provide more strain maps, but for the moment we have this one, which shows the central part of Europe. So it shows the dilatation, and then you can also here visualize the maximum strain or the minimum strain or the shear stress. And then you can find here the documentation. So the explanation how the strain was computed, and you can download it so you get the file which was used to plot this these data. Okay. So far I've been talking about the products using this browser, but if you have some automatic way of doing it, so it's very good to browser to explore what's available, with products they are, how long the data is. But if you have some repetitive or you want to automate it, then it's not so convenient, and then it's better to use the API. Paul yesterday already talked about Glass, and the browser is just on top of the Glass framework. So we have a Glass node, and then you can browse the API. So here, if you want to automate your queries of the products, this is the best way to get to know this. So I just want to give some examples. So let's suppose you want to know which stations have products. So you go to this, CATS products. It's a nice swagger. And then you can, here are some examples. And so let's find all the stations with products within a region. Here a rectangle. Try out, here, copy in. So let's see if it works. So this is live querying the database, and yes, it's working. So here you can see in a JSON object all the stations, X, Y, and Z coordinates with products. So this is, you can play around with that, and then you have here your curl command, which you have to automate. But so this just gives you an idea how to work with that. Another one which is very nice is the velocities. So here the velocities. So here it's the products, velocities, marker, analyze center, coordinates, and format. So let's try it out. So analyze center, let's say Europe, Europe. Coordinate system, east, north, up. Format, JSON. And let's do the floors one again, execute. So it's directly here. So you get this JSON object back where you can see your reference frame. You can see the east, north, and up velocity in meter per year and the DOI. So here again, you have then here the curl command, how to get it. So this is a very nice way to query also the product portal or to get the products from our TCS. So then finally, I want to say a bit more about how to get these RESTful APIs in a Python example. Okay, where is my key? So here I have a simple Python script. It's in Python 3. It makes use of the request module. So when you write your Python script, you have to import that. And then here I define just a helper function to get the basic URL. So this is you put it in front. And then here is the Swagger function. So I showed you two before about products, velocities, marker. And this one here, it's about stations to get within a box. So all the products here, you can put here the limits, geographical limits. And so it's calling the RESTful API using the request module, get command, and it puts the result in this variable, resp. And then if something goes wrong, an error is raised, it's shown. If it goes well, then this is converted into a JSON object, and then for each object in here you can analyze it. So it's like a dictionary, so you can select the block you want, and then you can select from that. So this is with a subblock. So here I select 4 character ID, the first 4. Then the properties, so this is subblock, you select it, and then you can get the city, the dummy. So this is the way you do it. You get your URL, you get here the Swagger, the API command, you get it, and then you convert it into a Python and then treat it as a dictionary in the rest of your Python script. So it's pretty easy. So this is also the way you have to do it. This is the principle to get for velocities. You change it here into products velocities marker, and then you can, in an automatic way, get your velocities. So this is a bit what I wanted to tell you. So I would like to thank you for your attention. And if there is any question, I will try to answer them.
Hey, thank you. We have already one question. Please, if you have any also more questions specific about the products portal, please also let us know. But there is one question already from Farah Mars. Sorry if I don't pronounce very well the name. So I think it's also quite a comment. But please, can you make your question?
Hello, everybody. This is Farmars Del Forushan from Lantmäteriet, Sweden. Thank you for the presentation. Actually, yeah, as you said, this is not a question. This is kind of comment. And I noticed, I think, when changing the reference plate for the velocities, the velocity vectors on the map was not changing. I think for the visualization will be interesting to change it as well.
Yeah, no, that's was also, I have got this comment also already from my members of the EPO within the group. Why it's not been done yet is also it's for the moment it was pretty optimized for speed. We have to work on getting it better. So for the moment it's like this, but of course we will improve it, and then because then if you do absolute velocity plate, no red rotation, it should be the long vectors, and so it should adapt. Yes, but it's we're in the pre-operational phase, so these are the kind of features we have to add to make it more attractive, of course.
Sure, thank you.
No, and we really appreciate, this kind of feedback from all of you. This is also one of the additional reasons to have it to do this webinar, is hoping to have feedback from you. I'm not sure if there is any other question from Mariel. I'm not seeing here in my chat, but okay. If not, I would suggest that we break for 10 minutes for the people that really need to have a coffee. But as I was proposing in the beginning of the of today, maybe will be nice to anticipate the session of question and answers in order that we can have a long